Okay, so we tried this one here, and we found out that it worked in both. So we're plugging it into equation 1 and equation 2. So this was equation 1, equation 2. It worked in both. So 2, 5 is a solution, the ordered pair 2, 5. Because you're getting that mixed up with just like a regular equation. These are two equations. Now I'm going to review how to graph. Okay, so we're going to review. We're going to do this together. Graph each equation in figure 2. Y equals 1/2 x plus 4 and y equals 3x minus 1. Now, you probably love those equations because they're already written in slope-intercept form. That was the hard part about that group work that I gave you earlier. It wasn't written like this. So you know what the slope is and you know what the y-intercept is. And by the way, with our graph, I always want you to set it up like this. Ready? This is how you're going to set up all your graphs. Y-axis, label it. X-axis, label it. That's labeling the axes. Now we're going to determine a scale that we want to use. Let's use a scale of 1. So if I go 1, 2, or 1, 2, if I skip count 3, 4, 5, 6, that's still using a scale of 1, right? It's just I prefer it like this, labeling every other line. 2, 4, 6, -2, -4, -6, 1, 2, 3, 4, 5, 6. So you want to put scale, you want to put numbers on there. So that's what I want to see on the graphs. And then to graph using the slope and the y-intercept. Who can tell me how to do that? Who remembers? Well, how would I graph y equals 1/2 x plus 4? Yes. 0, 4. I love it. Y-intercept 0, 4. Okay. Yes, the slope is rise over run, go up 1 over 2. Up 1 over 2. Now, tell me this. If you hadn't taken Math 60 last term, do you think you would have remembered it that fluidly? Like, no. It was a good review? Okay. You recommend it? If people, yeah. Okay. Down 1, back 2. Down 1, back 2. Down 1, back 2. I only remember this stuff, you guys, because I've been doing it for the past 16 years, like every single day. Doesn't that sound fun? All right, there's our line 1. Does everybody understand how she explained to us to do that? Who can explain how to do the next one? We start with the, yes, y-intercept, 0, -1. So we're going to start on the y-axis at -1, 3 over 1. Up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. Yes, because that's how you make a whole number into a fraction. You put it over 1. This is equivalent to -3 over -1. Do you agree with that? A positive number could be equal to a negative divided by a negative. What's a negative divided by a negative? A positive. So if I go down 3, 1, 2, 3, backwards 1, down 3, 1, 2, 3, backwards 1, you see those points are all collinear. They're on the same line. And the more points I have, the more accurate my line is going to be. Now that I have the two lines graphed, what is my solution? 2, 5. And actually, we saw that earlier, this point 2, 5, it worked in both because it was the solution, right? The solution works in both. The solution is where they cross. So we say the solution is 2, 5. Now, if I hadn't already plugged it in and seen that it worked on both, I would require that you check. And you should check. This is the same thing right here. This is the check in both. I cannot emphasize checking in both strongly enough. Because if you graph one of the equations wrong, okay, sometimes people put the y-intercept on the x-axis. I don't know, crazy things happen. If you graph the lines wrong, they're going to cross, maybe, but the point might not be the right point. The only way you'll know is if you plug it into both equations. Okay? Does that make sense? How many equations are you going to check it in? 2. So I would see, there's not enough room here. I would see a check, but really we have the check up here. That's what the check looks like. And people will tell me they know how to get the answer, but they don't know how to check it. No, we know how to check it. We know how to plug the numbers in, see if it works. If it doesn't work, it's not right. And probably one of the lines is graphed incorrectly. Okay? Now it's your turn. Go ahead and try that.